Hello everyone, welcome back to this channel. Today we'll be doing something a little bit different. We'll be deriving ideal gas equation and mean square speed equation in the next video because I have a plan to discuss a thermodynamics question from the winter 2024 paper. I saw a very interesting question and I believe that it's good to discuss. However, before we discuss, I believe it's best we know how to derive the equations first, as it will serve us as a prerequisite knowledge before we get into the question so that you can understand better, right? Okay, let's get started with the ideal gas equation. Okay, we know PV over T is equals to a constant. Am I right? And P is pressure, V is volume, T is temperature. This is what we all know. Now, what is the constant? This constant is denoted as R. What is R? R is actually the universal molar gas constant. It is the universal molar gas constant. And the value is actually 8.31 joule per mole per Kelvin. This is the universal molar gas constant. Okay, now this is for 1 mole of gas. What if you have a lot of moles of gas? Then you will have PV equals to nRT. How do I get this? Because we know PV over T equals to R, right? I bring my TR there. PV equals to TR. Now this is for 1 mole of gas. If I have a lot of moles of gas, I have to use this formula. N is number of moles. Yeah. So that's the first formula. Is it right? PV equals to nRT. Now what if they give you number of gas molecules? Okay. So we know, if you have taken chemistry, you might have known this, but you have not taken chemistry, that's okay. No worries, we'll do it together. There's a formula called number of moles is equals to number of gas molecules over Avogadro constant. Not avocado constant, yeah? It's Avogadro constant. Or usually people denote it as capital N subscript A. Okay, and the value of Avogadro constant is actually 6.02 times 10 to the power of 23. Okay, now this is the formula. Number of gas molecules over Avogadro constant, Na. And number of gas molecules usually denoted as capital N. Okay, now let's say in the question, they did not give you a number of moles. They give you a number of gas molecules. So how can we calculate it? We can actually derive a new equation from this. Okay. We know PV is equals to nRT. And we know N is equals to capital N over capital N subscript A. Am I right? Okay, so we sub in this here. N over NA. Put a bracket. RT. Okay. Alright. Now, we know that this one, Avogadro constant, and R, which is our universal molar gas constant, is a constant. Right? What I'm trying to say is, these two is a constant. That means it's a fixed value. We can't change it. So what we can do, we can actually combine these constants together, which will give us PV equals to N R over NA T. So this whole thing is a constant. Now what can we do? We can actually name the constant NKT. This constant, I name it as K. And this K is actually known as Boltzmann constant. Yeah, I'll write here, this K is actually equals to R over Na, or in other words, it's 8.32 over 6.02 times 10 to the power of 23. So this is your new formula. So first formula is when you have number of moles. This is the first formula. Now let's say the question did not give you number of moles, they give you number of molecules instead. Can you find? Of course you can still find using this formula. So make sure you know how to derive, because sometimes they might ask you in exam. So that's all about it for this ideal gas equation derivation. I'll see you in the next video where we talk more about how to derive mean square speed for ideal gas molecules. Okay? See you in the next video. Bye bye. Thank you.